Hi, people. Note 6.6 are on the sine law. So all the trig that we've done so far in this unit has only dealt with right triangles. But we can use trig for triangles that are not right triangles. So what happens if we have a triangle that is not a right triangle? And the name of a triangle that's not a right triangle is called an oblique triangle. Okay, so if the correct information is known, we can use something called the sine law, and that can be used to determine the side lengths or the angles of any triangle. So let's talk about this right here. Okay, so for starters, in order to use sine law, the triangle must present a matching pair. So a matching pair. A matching pair is the term given to an angle and its corresponding side. Opposite of the angle. So the first thing we need to do is to be sure to correctly label the triangle to identify any matching pairs. So the triangle's vertices are labeled with capital letters. So that's like where the angles are, where the sides meet, while the corresponding sides, the ones that are opposite of the vertices, are labeled with lowercase letters. So for example, on the triangle below, label each vertex with A, B, and C. So I'll just call this A, I'll call this B, and I will call this C. Notice how the vertices are using capital letters. I've decided to color code this, okay? To figure out what the lowercase letters are going to be, it's always the sides across from the angles. So if this is vertex A, if this point right here is vertex A, angle A, then this side across from it is little a. If this is vertex B, then the side across from it is side B, lowercase b. And if this is vertex C, then the side across from it is side lowercase c. So whenever you are given a capital letter, it is a vertex. Whenever you're given a lowercase letter, it is a side length. Okay, so let's talk about this. We're going to talk about what the sine law really means. If you take a look at what we have in front of us right here, we can see that we have triangle ABC. And if you notice, vertex A is in red, and the side across from it is lowercase a, that's also in red. Vertex B is in blue, the blue side across from it is lowercase b. Vertex C is in green, the side across from it is in green. Okay, so red is A, blue is B, green is C. So if you look right here, it tells you in this example that the angle that's given to us for angle A is 94 degrees. The side across from it is 8. If I were to take the sine of this 94-degree angle and then divide it by the side across from it, I would end up getting 0.13. Okay, notice how if I were to look at B right here, for B, if I were to take the sine of B, which is 43 degrees, divide it by actual B, which is 5.4, so that's what it says here, I would also get 0.13. Let's take a look at C right here. So if I were to take the sine of C, which is also 43 degrees, divide it by what C is, which is 5.5, I would also get 0.13. So now I'm going to show you A, B, and C, and notice how no matter what the angle measurements are, notice that the angle measurements are changing, right? So like, for example, look at angle A right now, it's 66 degrees. It's now 110 degrees. Now it is 39 degrees. And all these angle measurements are changing. The side measurements are changing. Even the ratios are changing, right? Like right now it's 0.2. Now it's 0.14. Now it's 0.16. No matter where I put it though, the ratios match up with each other. So if I take the sine of A divided by the side across from it, it will equal the sine of B divided by the side across from it, which will equal the sine of C divided by the side across from it. And that's a really important relationship that will help us solve for missing pieces in triangles that are no longer right triangles. So when solving for a side length, you must know at least 2 angles and 1 side length, okay? And just a reminder that all angles will add up to 180 degrees. So this is the formula for sine law, and it's just what we had looked at right now. So if I take side A and divide it by the sine of A, that ratio is going to be equal to side B divided by the sine of angle B. Sorry, if I said side A here, I meant to say angle A. And that will be also equal to the ratio of side C divided by the sine of angle C. Okay, and then you can solve for an unknown side length using cross multiplication or isolation. This is an equation that you need to make sure that you have memorized. So really it's just the side over the sine of the angle across from it, okay? So let's take a look at what we have here. In this example here, the first thing I want to do is label my lowercase letters. So I know that this is angle A, so this is going to be side A. This side right here is side A, okay? I know that this is angle B, so this side across from it is B, so B is going to be 17. And I know that this is angle C, so the side across from it is lowercase c, and it says to solve for c. So this is what I want to know. Okay. In order for me to be able to do this, I need to have a matching pair. We've already said this, but I'm writing this again because it's just really important that you know that it needs to have a matching pair. So if you take a look at what we have going on here, we know that angle B right here is 23 degrees. And we also know that the side across from it is 17 meters. So this is our matching pair. We've got capital B with lowercase b. So I'm just going to write this out for you really quickly. So this right here is going to be A over sine of A equals B over sine of B is equal to C over sine of C. So I know this pair right here. I know little b and I know sine of b. So this is some information that I do know. I'm going to use this in my ratio, okay, or in my proportion, I should say. And I'm trying to find c. So because I'm trying to find c, I'm also going to want to use this. A really isn't going to help me out because I only need two pairs for me to be able to do this. I'm going to be using b over sine of b is going to be equal to c over sine of c. But here's the thing that's a little bit tricky. I know b. I know that b is 17. And I know that sine of b is going to be the sine of 23. But on the other side, I'm trying to find c, and I need sine of c, but I don't know what angle c is. But I do know that this is 81 and this is 23. So we have to find c first. How do we find c? We know that the angles in a triangle add up to 180. So C is just going to equal 180 minus the sum of 81 plus 23. So C is going to be 180 minus 105. So C is 75 degrees. So now we know that this is going to be 75. Okay. I'm going to zoom in on this so you can see what I'm doing here. In order for me to be able to solve this, I have to cross multiply. 17 is going to get multiplied by the sine of 75. So I'm going to write down 17 sine of 75. On the other side, it's going to be c times the sine of 23. And in order for me to isolate the c, I just have to divide everything by sine of 23. So I get 17 sine of 75 over sine of 23. So just so that you know, I'm just dividing by sine of 23 right here. This goes away. Whatever I do on one side, I do on the other side, but I just don't love to show that step out because I don't want you to think that once I get to the cross multiplication, it's another fraction. So I'm just going to go ahead and type that into my calculator. So I'm going to do 17 times the sine of 75, and that's going to be divided by the sine of 23, which means that my answer here would be 42. So here I can say that C is approximately 42 meters. And that's my answer for this. Okay? All right, for our next one, we're trying to solve for an angle this time. So in order to be able to do that, you must know two sides and the corresponding angle for one of the known sides. And the sine law formula for solving a side length is as follows. So it's exactly the same thing, except we just put the sine on top. So sine of angle A over little a is going to be equal to sine of angle B over little b, which is going to be equal to sine of angle C over little c. And I'm going to be completely honest with you. I personally never switch the order. I just memorize one of them and then I just use the one. It really doesn't matter to switch the order, but if this helps you, then feel free to use this, okay? And by the way, this should say the sine law formula for solving an angle is the following. Okay, so you can solve for an angle for an unknown side length using cross multiplication or isolation, just like we said before, but eventually we're going to have to use inverse sine, and I'll explain to you what I mean by that. So here we want to find out our angle. The angle that we want to know is angle A right here. Okay, so this is our x. This is what we don't know. So the angle that we want to find out is angle A. If this is angle A, we know that this side right here will be side A. Okay, and we need to have another angle and its opposite side in order for me to be able to do this. So here I know the other angle is 36 degrees. That's angle C, and the opposite side that we know is this 21 right here. So we do have a matching pair, so that's awesome. So remember, it's sine A over little a equals sine B over little b equals sine C over little c. We know sine C and little c. We want to find angle A, and we know little a. So these are the two parts of my ratio, my proportion, excuse me, that I'm going to be using. So I'm going to write out sine A over little a is equal to sine C over little c, or side C. So I don't know the angle, so I'm going to keep this as sine A, and then over little a is 33. And that's going to equal sine C, which is 36 degrees. So I'm going to say sine of 36 over little c, we know is 21. Okay, I'm going to go ahead and cross multiply these values here. So watch very carefully because this one's a little bit trickier. Here I'm going to multiply 21 by the sine of A. So I'm going to say 21 sine A. And that's going to equal 33 times the sine of 36. And in order for me to isolate A, I have to isolate sine of A first. So I need to get rid of this 21 by dividing. But again, I don't want to show the division because I don't want you to think that this is going to end up being a fraction when I cross multiply. So I get 33 over sine of 33 times sine of 36 over 21. Notice how I have not typed anything into my calculator yet. Now, to get the a out of there, this is where I'm going to do inverse sine. So I'm going to do inverse sine of 33 times the sine of 36 all over 21. And then I'm going to go ahead and type that into my calculator. So don't forget, you're going to go to function, inverse sine of, and then the nice thing about Desmos is if you press the division key, it gives you the fraction right here. So I'm going to type in 33 times the sine of 36, and don't worry, in class I will show you how to do these in the classroom calculators, all over 21, and we end up getting 67 degrees. So this right here is going to be A is 67 degrees. Okay? All right, so now we have a sine law word problem. So it says a 3-meter fence. I'm going to call this A because that's information that's given to me, which means that this is angle A right here, is leaning so that it makes a 65-degree angle with the ground. So I'll call this B because we know that, which means that this is little b. A 4-meter long brace is used to stabilize the fence. So here's the brace that's stabilizing the 3-meter long fence. What angle does the brace make with the ground? So I'm trying to solve for angle A, and I have a set of B's. Okay, so when I set this up right here, I'm going to just use sine of A over A is equal to sine of B over B. Okay, so here when I do this, I can just fill in that information. I don't know what A is, angle A, but I do know that side A is 3. I know that angle B is 65 right here, and I know that side B is 4. Now I'm just going to go ahead and cross multiply. So I'm going to cross multiply this 4 by sine of A, so that gives me 4 sine A, and then I'm going to cross multiply 3 by sine of 65. I don't like that 4, so I'm going to get rid of it by dividing. And then I'm going to do the inverse of sine. So I'm going to do inverse sine of 3 times the sine of 65 all over 4. Okay, so let's go ahead and type that into our calculator. So I'm going to go to function, inverse sine of, I'm going to go back to main, press the divides key to get that fraction inside of there. I keep forgetting what the numbers are. So we're going to do 3 sine of 65, and that's all over 4. Sorry if I'm making you dizzy. This would end up being 43 degrees. So A equals 43 degrees. So we can say, therefore, the angle the brace makes with the ground is 43 degrees. And we are done with this question in this video. Let me know if you have any other questions. Have a good day, and I'll see you later. Bye.